Mathematics at Init College, a YouTube channel for high school mathematics education. Mathematics 3C and Mathematics 4, Swedish education system. The definition of the derivative. Hi, this is Babak. In this video I am going to solve the following problem for you. Use the definition of the derivative to determine the derivative of the following function. f of x equals to square root of 3 minus 2x. I would recommend you that you pause the video now and try to solve the problem yourself first. If you do everything correctly, the answer that you will get at the end would be f prime of x equals to minus 1 over square root of 3 minus 2x. Okay, now let us solve the problem. Because it has been mentioned in the problem that I'm supposed to use the definition of the derivative to find this derivative, so I will start the famous definition of the derivative. F prime of x is the limit of f of x plus h minus f of x divided by h when h goes to 0. Okay, so then this becomes the limit h goes to 0. We have h in the denominator, so you see I have a negative sign here, so I put that negative sign, and then on the right hand side I have my function f of x, which is this function, so I would write square root of 3 minus 2x, but on the left hand side I have f of x plus h. It means that I need to go to my function and I need to replace every x that I see there with brackets x plus h. So this is the only place that I see x, so I just take it away and write x plus h in brackets instead of that. So then it becomes square root of 3 minus 2x plus h. h goes to 0. So of course you see that right now I cannot put h equal to 0 because the denominator becomes 0. So what I need to do, this is a trick that you need to know, we need to multiply the numerator and the denominator by the conjugate of the numerator. So what does it mean? It means that I can write this fraction once more, but let me just multiply 2 inside, so it becomes 2x plus 2h, but there is a negative sign, so it becomes 3 minus 2x minus 2h, and then I have the second square root is 3 minus 2x, and in the denominator I will have h goes to 0, but what I do, I rescale this with the conjugate of the numerator. So this becomes square root of 3 minus 2x minus 2h plus square root of 3 minus 2x. And then I will divide by the same expression because I don't want to change actually the fraction. So this is a trick that you need to learn when you are dealing with the square root sign. So you see here this expression is actually 1 because the numerator and the denominator are equal. So it means that I am multiplying my fraction by 1, which would be the previous fraction as is expected. But what is the benefit of that? The benefit is that if I want to multiply these two things, this makes a conjugate pattern for me. So if I have a box minus the circle, whatever inside these two shapes, if I have the same two added together, this becomes a conjugate pattern, and it gives me the first one to the 2 minus the second one to the 2. So now this one is playing the role of the square, and this is playing the role of the circle. So, and then you see that this is the square minus the circle times the square plus the circle. So this gives me this answer that this is the limit, the first one to the 2, which will remove the square root sign, yes, minus the second one to the 2, which will remove that square root sign as well. In the denominator, what I do, I have to multiply the denominators, so I will multiply this in this form. So it is h times 3 minus 2x minus 2h plus square root of 3 minus 2x. and then h is going to 0. But then I open the pair of brackets in the numerator to simplify this expression. So the first pair of brackets I can just simply remove that, but for the second pair I need to be careful that this minus sign goes for 3 and minus 2x. So 3 becomes negative 3, negative 2x becomes positive 2x. And then I will just copy and paste the denominator. So this is h square root of 3 minus 2x minus 2h plus square root of 3 minus 2x, and h goes to 0. But now you can see that this negative 3 and this positive 3 are gone, this positive 2x and this negative 2x are also gone. So what is left for me is just the limit minus 2h, and in the denominator what I have is h multiplied by square root of 3 minus 2x minus 2h plus square root of 3 minus 2x, and h goes to 0. But of course in this case you see that h is a factor of the numerator as well as the factor of the denominator, so I can cancel them out, and then what is left for me in the numerator is just simply minus 2, and then this becomes the square root of 3 minus 2x minus 2h plus square root of 3 minus 2x, and h goes to 0. Okay, now I can simply plug h equal to 0. So h is supposed to go to 0, but when I plug h equal to 0, nothing odd happens, so this becomes minus 2. In the denominator I will have square root of 3 minus 2x plus another square root of 3 minus 2x. Okay, but they are the same. They are the same expressions in the denominator, so I can add them and write 2 times 3 minus 2x. Yes, 2 times the square root of 3 minus 2x. They are the same thing, and I have a negative 2 in the numerator. But finally, this negative 2 and that 2 in the denominator will vanish, so I can simplify. It becomes minus 1, and this is totally gone. So that's exactly what was given in the beginning of the problem as this answer to the derivative of this function. So 3 minus 2x. Okay, so that is the derivative to this function. I hope that you found the video helpful. The PDF file, you can find the link to download the PDF file of these notes that you see now. Until the next video, be safe and goodbye.